Okay, here's a review of our Check Your Understanding problem from today. As you'll recall, what we had was a prompt where we talked about grandparents who had these really outlandish stories about 10 plus miles to school, uphill both ways. A random sample of 180 teenagers were selected. 40% had heard these stories. So we wanted to know if there was significant evidence that that there's a difference. Is there a significant difference? Do these data provide convincing evidence at the alpha equals 0.5 significance level that the proportion of teenagers who have heard stories from their parents or grandparents about how difficult life was when they were kids differs from 50%? So we have a sample that represents 40%. So is it different than 50? Yes. Is that convincing evidence? No. Is it some evidence? Yes. So we are going to run this one sample z-test, and that's what we kind of outlined here in the middle. One sample z-test. Because we are using proportions, we have a z-test. Now, our sample, once again, does represent a difference from 50%, but is it a significant difference? So that would be like saying, I happen to get this 40%. Could it have happened by chance? Well, what we do is we lay out everything. So here's our parameter. Here's our h sub 0, which we are assuming is true. Now, how do we determine our alternative hypothesis? It's all about the prompt. Now, sometimes the prompt is going to say, do you have convincing evidence that one is greater than the other? Do you have convincing evidence that one is less than the other? Our prompt, however, says, do you have convincing evidence that it differs from 50? What does it mean to differ from 50? Well, it could be a little bit less, or it could be a little bit more. And so in this case, we are doing what is called a two-tailed test, because we are not evaluating is it less or greater than, we're saying is it different from. So this is a two-tailed test. And if you think about what we've been talking about with the normal curve, you're going to see where we get this difference in our p-value pretty quickly here. So tested my conditions as per usual, laid out my z-score, make sure you know that formula, found that my z-score for what I got was negative 2.68. That is for that value that I got of 40%. Now, here's where the tricky part comes. In our picture, what we are doing is we are saying my mean is 0.5. What I was looking at was 0.4 because this is the value that I actually got. And typically what we've been talking about is finding the p-value for 0.4 or more extreme. So like 0.3, 0.2, 0.1. In a two-tailed test, what we're saying in statistics is somebody randomly walked out, picked these people, they got 40%, and it seemed like an extreme answer. In statistics, this difference right here of negative 2.68 z-score or 2.68 standard deviations is the same likelihood as having something that's 2.68 standard deviations above 0.5, which means that we are equally likely to get 60% as we are to get 40%. And the reason why this is because in our curve, they are symmetrical. So the probability that I get 40 or below is the same exact probability of getting 60 and above. And it's all about the standard deviation. So it's equally likely. It's like saying you get the test back and someone says, man, I did really poorly. I got a 45%. And you determine that that's 3 standard deviations below the mean. And someone goes, wow, I did way better than I expected. I guessed on all of them. I got 3 standard deviations above. In statistics, we would say those are equally likely to happen. Somebody just happened to guess poorly and got 3 standard deviations below, as the other person guessed really, really well and got 3 standard deviations above. So when we get to our p-value over here for the z-score of negative 2.68, we get 0.0037. But because it's a two-tailed test, we're saying the extremeness of the answers, either 0.4 and below or 0.6 and above, indicates that we have to multiply it by 2 because we're not saying is it greater than or less than. We're saying is it different from. So in our conclusion, we have to say there's a 0.0074 probability of getting 0.4 or lower or 0.6 or higher purely by chance because it's below the alpha level, we reject h sub 0, et cetera, et cetera. And then when we go down to this number 2 part, what they're saying is they constructed a 95% confidence interval, and it was this. And because 0.5 is in the middle of there, should be in the middle somewhere if it's included, we can say, well, it's not actually in there, so it's not likely that 0.5 is actually the true proportion. It does give us additional information, so explain how the confidence interval, but gives more information. It actually gives us a ton more values. So whereas our test just said, well, it's not likely, the confidence interval gives us a range of values where it could be. So that's the basic gist of this example, and let me know if you have additional questions on that, but that differs from right there. So this differs from prompt really indicates that we're doing that two-tailed test. So keep an eye on that verbiage when you get a prompt on the AP exam. All right, thanks for watching, and we'll see you next time.